Alright, hi guys. So here we have the CAPS November 2018 paper 1, grade 12 mathematics. Right, so question 1. And we always start with the same kind of idea, it's just algebra in the first question, almost always. So let's just get started with question 1, solve for x. Okay, so we see the first one, I'm just going to rewrite the question, 1.1.1. So here we have x squared minus 4x plus 3, x squared minus 4x plus 3 equals 0. Yeah, so it's a quadratic equation because we have an x squared, an x, and a number. And now how do we solve this? Well, there are many ways we can solve this. I'm going to use factorizing. So this one can factorize quite nicely. So we know it has the two brackets. And then we get x times x will give us x squared. And then what times what will give us 3? Well, the factors of 3 are 1 and 3. So it has to be a 1 and a 3. But if we add or subtract these two, let's make the 3 a little bit better. Then we need to get the middle term, the negative 4. So if it's minus 1 minus 3, that'll give us negative 4, right? And what is negative 1 times negative 3? Positive 3. So that's right, that's our answer. Negative 1, negative 3. And you can always check by multiplying back out if you get back to your original answer. Okay, so now we have something times something equals 0. So that means either the one thing is 0 or the other thing is 0. Or x minus 3 is 0 in this case. Okay, and then let's just make that a better 0. Now if we take over the 1, so we get x equals 1 or x equals 3 if we add the 3 to the other side. There we have it, x is 1 or x is 3 for question 1.1.1. Now let's look at 1.1.2. Should we do it in a different color? Let's stick to this color for the whole 1.1 and then we'll switch to another color for 1.2 and 1.3. 1.1.2, 5x squared minus 5x plus 1 minus 5x plus 1 equals 0. Alright, now this is a good hint. If we see solve correct to two decimal places, then we know it's not going to be able to factorize. So that we can either use completing the square or we can just use our quadratic formula. I think it's better just to use the quadratic formula, or at least quicker, because you can just use your calculator. So x equals negative b. What is b? b is negative 5, right? So we've got negative b plus or minus square root of b squared minus 4ac. Let's write the formula down here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, so that's the formula we're using. We've already got the negative b, this part here, and with plus or minus square root b squared. So b again is negative 5, so we're going to have negative 5 squared minus 4 times a is 5, times c. And what is c? c is 1. Alright, all over 2 times a, and a is 5. Alright, now the nice thing is we can just type this whole thing in the calculator. I'm just going to simplify it. Maybe that's going to be good for us to just practice a bit of simplification of roots and surds. So that might be helpful in some of the other questions to come later. Negative 5 is positive 5, plus or minus, we've got the square root, and here we can just calculate this. Negative 5 squared is 25, and let me just check if I can, okay, 25, and then minus 20. So that's just 25 minus 20 is 5, right? So square root 5, and at the bottom we've got 10. Right, so this we can type in the calculator. Maybe let me open a calculator and let's actually do that so we can get to the answer. Alright, so we've got, let's do first the plus, 5 plus the square root of 5. And that answer we divide by 10. So 0.72, correct, two decimal places, right? So 0.72. So x equals 0.72, or, and now we're going to do a minus. So 5 minus the square root of 5. And we're going to divide that by 10. So 0.28. If we round the 6 turns the 7 into an 8. 0.28. 0.28. Good. So that's 1.1.2. Let's get to 1.1.3. 1.1.3. Right, so we've got x squared minus 3x minus 10. X squared minus 3x minus 10. And that's going to be greater than 0. Instead of an equal sign, we've got a greater than. Right. So we're going to start off doing it the same as if it was an equal sign. So this one can factorize again, which is nice. So we factorize that. So x, and then factors of 10 are 1 and 10, or 2 and 5. And a 2 and a 5 can get us to 3. So if we have a minus 5 and a plus 2, that gets us to 3. And negative 5 times positive 2 is also negative 10. So that's right. Now the critical part. This is where lots of people make mistakes. So the part that you don't want to do, let's do that in red. What you don't want to do is you don't want to say x minus 5 greater than 0 or x plus 2 greater than 0. Right? This is wrong. You could have done that if it was an equal sign, and that's why I think some people think we can do it with an inequality as well. But that's not going to be true. So what we want to do is we want to say, let's find our critical values. So we have to write something like this or do it in rough word, because now we're going to use an equal sign, which is not what the question says. So for critical values, we're going to say this equals 0 and this equals 0. So if we say x minus 5 equals 0, we'll get x equals 5, or x equals negative 2, right? If we put this equal to 0. So this is now our critical values. What we want to do with this is we want to put it on a graph. Right, so those are x-intercepts, so at negative 2 and at 5, so something like that. And this is a parabola, right? X squared. It's got a positive value here, so it's a smiley face. So we want to do a quick sketch of this graph. We don't really care about what the y-intercept is, but we can see it's negative 10 there, just from reading off the graph. The important thing is the x-intercepts, which you just found here, to be negative 2 and 5. Because, what does this question say? It says, where is this graph bigger than 0? So where is it above the x-axis? Where does that have positive y values? So we can see that's everywhere. All the x values left of negative 2, the graph is going to be above the x-axis, right? So we know x must be less than negative 2, or x must be on that side of 5, so greater than 5. Okay, so very important. You find your critical values by solving it as if it was an equal sign. So this you do in rough work, or you write down critical values or critical points or something of that sort, as just so you don't say it's part of your calculation to an equal sign when it actually should be an inequality. Right, and once you have that, you draw a little drawing and you check where's the graph, above or below. In this case we want above, because greater than. We check which x values will have the graph above the x-axis. If it was less than 0, that would be which x values would be below the line. So that would be all these ones would have the graph below the line. Okay, good. Hopefully we'll see some more questions like this in some of the other papers. So if you have any questions on how this works or what happens, just check out some of the other question papers. All of them have some inequality somewhere in them. Okay, that was 1.1.3. Now 1.1.4, let's go on at the bottom here. 1.1.4, here we have this question. 3 root x equals x minus 4. 3 root x, I'll just rewrite that. 3 root x equals x minus 4. We need to solve for x. Well, what's the problem here? Well, the problem is we've got a root, and we don't like those root signs. So what we're going to do is we're going to square both sides to get rid of this, right? So we'll square the left-hand side and we'll square the right-hand side. And important to remember, we're squaring both sides as a whole, not each individual term. That's also something that some people get wrong. So some people, let's do a red one again. Some people say, okay, square the left-hand side. We get 3 squared is 9, square root of x squared is x squared is x squared, and 4 squared is 16. This is a problem. We want to square the whole side, not just each individual term. Okay, so let's see what happens when we square the whole side. Then remember, the bracket has to be multiplied by itself. So in this case, if we multiply this bracket by itself, we get 9x. In this case, we multiply it by itself. We don't get x squared minus 16 or x squared plus 16, because multiplying the bracket by itself means we do x minus 4 times x minus 4, and then we do this method, right? Multiplying everything by everything. So if we do that, it all simplifies to x times x is x squared. X times negative 4 is negative 4x, and we do that again, so negative 8x, and then negative 4 times negative 4 is plus 16. You can verify this by just multiplying out the bracket. I'm just skipping that step now. Okay, now let's see if we can get everything to one side equal to 0. So we've got x squared, negative 8x minus 9x is minus 17x. We still have our 16. And now again, this one can factorize nicely. If you can't factorize it and you're struggling with the factorizing, just put it into the quadratic formula, right? That's fine. Okay, so this is x minus 16 and x minus 1. Again, we can see minus 16 times minus 1 is positive 16, and minus 16 minus 1 is minus 17. So that works out. So that gives us x equals 16 or x equals 1. Right, and now we just have to check our answers when there is a root involved. I'm going to leave that for you guys to do, to check. Well, actually, maybe let's do it. Let's work through that. Okay, so let's do a test just to see if it works. Okay, so we had 3 times the root of x. And x, let's test this one first. So root 16. And the other side must be x minus 4. X is 16. Okay, so 3, what is the square root of 16? Either 4 or negative 4. So let's try it with a positive first. And 16 minus 4 is 12. So 3 times 4 is 12. Okay, 12 equals 12. That's correct. It works. Now let's test it with a 1. So we've got 3 times the root of x, which we're going to say is 1, equals x, which is 1 minus 4. So 3 square root of 1 is 1 or negative 1. Let's try it with a positive first. So 1 minus 4 is negative 3. So 3 equals negative 3. That's wrong. That doesn't work. Okay, let's try it with a negative 1, because the negative 1 is also the square root of 1, right? Because we've got plus and minus. So negative 1, 1 minus 4. So negative 3 equals negative 3. Yes, that works. Okay, so we see both answers work. So that's fine. If one of them doesn't work, we have to cross it out or write not applicable. Good. So that was question 1.1. Now let's head to question 1.2. 1.2. Solve simultaneously for x and y. Okay, I'm just going to rewrite this equation. So this one I'm going to rewrite in the form y equals. So I'm just going to take the y over and have the 3x minus 2 on the other side. Okay, so y equals 3x minus 2. That's the one equation. And now the other one is 2y plus 9. Let me just rewrite that. Maybe it's a bit small up there to see. 2y plus 9x squared equals negative 1. Okay, so what are we going to do? We know what y is, so we're going to substitute what y is into the other equation. So in this equation we had 2 times y, but we know y is 3x minus 2. Right? Y is 3x minus 2, so we just put that in. Plus 9x squared equals negative 1. Right, now we're just multiplying. 2 times 3x is 6x, 2 times negative 2 is negative 4, plus 9x squared equals negative 1. Okay, again we can see it's a quadratic equation because there's an x squared, an x, and numbers. So we're going to keep everything on one side and the 0 on the other. So let's keep the 9x squared, and then all the x's, so plus 6x. Then negative 4 plus 1 is negative 3 equals 0. Right, so we see we can take out a common factor here. We can divide everything by 3, which will make it a lot easier. So let's do that. Divide everything by 3, both sides. So this side becomes 3x squared plus 2x minus 1. And what is 0 divided by 3? Still 0. Nice. Now this one again can factorize. But again, if you're struggling with factorizing, just put it into the quadratic formula. No problem with that. Then we're going to have 3x times x will give us 3x squared. And then we're going to have a plus 1 and a minus 1. Because here we have negative 1x, here we have positive 3x. So 3x minus 1x is 2x. Okay, practicing factorizing is always a good thing, especially these quadratic trinomials. Now we can say this bracket is 0 or this bracket is 0. So for if this one is 0, let's just do the calculation. If that equals 0, that means that 3x equals 1. And that means that x equals 1 over 3. Or the other bracket equals 0. So x plus 1 equals 0, which means x equals negative 1. So those are two x values. Now we still need to find the y values. So we can just plug these two x values back into any one of our equations. I'm going to choose this one because that one has y by itself already. Makes it a lot easier. Alright, so let's plug it in. So let's say we use this value first. So y equals 3 times 1 over 3, right, for the x, minus 2, and then we calculate. So 3 times a third is 1, and then y equals 1 minus 2, negative 1. So y equals negative 1 when x is a third. Or, let's substitute this value in. So y equals 3 times, now we're going to put in a negative 1 in place of the x, minus 2. So y equals negative 3 minus 2. Y equals negative 5. So y equals negative 5. So these are our two combinations. And now it's good to write them. They often want you to write this in terms of coordinates, on coordinate form. So the one will be when x is a third, then y is negative 1. Or when x is negative 1, then y is negative 5. So just write in this form so they can see which ones belong together. Great, that was 1.2 or 1.3. What is this? Oh, this looks very interesting. 1.3. Okay, do we have enough space? Yeah, we have enough space. Let's change colors again for 1.3. Let's do this in green. 3 to the 9x is 64. I'm going to write that down so long. So let's use just blocking off this space here. 3 to the 9x equals 64. And what's the other one? 5 to the root of p equals also 64. And 5 to the root of p also equals 64. So we get given that, and we need to find what is 3 to the x minus 1 all cubed. 3 to the x minus 1 cubed over, and then it was root 5 to the root p. Yeah, root 5 to the root p. Root 5 to the root p. So we have to figure out what this equation is, what this expression is equal to, if we know that. Let's make the 9 a little bit more 9-ish. All right. So the top part here looks actually pretty straightforward. The bottom part here looks a bit dodgy, with the roots, all the roots involved. Now, to see how these two compare, right, how those two compare, I think that's where most people will get stuck. So let's have a look. Let's use other numbers first, where we actually know the answers, just to check what's going on. And I'm just going to do that over here in rough work. So we've got something to the square root of something as an exponent. So let's say we had 3 to the square root of 16. Right? So we know that's 3 to the power 4, and that's 81. Okay, we can see that. That works. Now, what is 3 to the power of the square root? Not 3, root 3. Okay, so root 3 to the power square root of 16. So we want to check this, right? That's analogous to 5 to the root p and root 5 to the root p. Let's work that. So square root of 3 we can rewrite as 3 to the power half. Right, and that's all raised to the square root of 16. And the square root of 16 is 4. Now we know from the laws of exponents, we multiply the exponents when we're raising them to powers. So half times 4 is 2, that gives us 9. 3 squared is 9. Okay, so we see this answer is just the square root of the original, right? So that is the square root of that. And that's going to obviously be very helpful. So we know this is just the square root of this. And we know this is 64, so it means this is 8, right? The square root of 64. So that is a very useful thing to know. All right, let's get on with it then. So the top part here, I'm just going to, I wonder what we should write first. Okay, let's just expand the top part. So we're going to say this is 3 to the power, and then 3x minus 3, right? 3x minus 3. And at the bottom, root 5 to the root p. We can just say that is the same as the square root of this whole thing. We know that's 8. We know that's 8. Okay, well let's just do write a few extra steps. Let's say it's the square root of 5 to the root p. Okay, we just proved that over here, right? With using some numbers. Okay, now here we can split it up the top part. So 3 to the power 3x times 3 to the power negative 3. And at the bottom, here we already know that is the square root of 64. So that is just 8. Now 3 to the power 3x, how does that compare to 3 to the power 9x? Let's do that in rough work as well. So 3 to the power 9x is what? That's just the same as saying 3 to the power 3x cubed. Right? So 3 to the power 3x is the cube root of this. So if we take the cube root of that and the cube root of that, then we get 3 to the power 3x equals 3 to the power 3x. Right? And that's all it is. So it's a cube root. 3 to the power 3x is the cube root of 3 to the power 9x. So what is the cube root of 64? That's 4. Okay, So this part here is 4, a cube root of 64. So we get 4 times 3 to the power negative 3. That's 1 over 27. And then 8 at the bottom. Okay, so let's do this in this way. I mean, this is just calculator work from here actually. So 4 over 27 divided by 8. Let's just practice some primary school. How do we divide fractions? We keep the top, we have a fraction divided by a fraction, we do this, and we change the divide into a multiply and we swap this one around. So 8 over 1 becomes 1 over 8. So let's take top times top, 4 times 1 is 4, 27 times 8 is 216, and then we can simplify this, right? Both 4 can go into both, so we divide both by 4, top by 4 and bottom by 4. So 1 over 54. This is a tricky question, really tricky question. If my explanation wasn't clear enough, play around with these numbers just to get an idea of why this works. Because I mean, it's one thing to just tell you that this is the square root of this, but it's much nicer if you play around with some numbers and actually check that it works and why it makes sense. Alright, and the same thing obviously 3 to the power 9x. You know that if we take the cube root of this, we can rewrite that as 3 to the power 9x over 3, right? Inside over outside exponent. And that just gives us 3 to the power 3x. So you see the cube root of that is 3 to the power 3x. So we know that this is the cube root of that. And the cube root of 64 is 4. Right, I hope this was useful for question 1. We'll be back with question 2.